So welcome everybody to this latest KS3 GCSE video on squares, cubes, powers and roots, and in this video we'll go over what is meant by powers, what is meant by roots, and also how to use your calculator when working with this topic. So a power, or more mathematically known as an index, is used when a number or a base number is being multiplied by itself multiple times. So if you see something where you've got a big number, then you've got little number just above on its right hand corner, then this is basically what it means. So our 3 is our what we call the base number. And it's not really called the base number at lower school, it tends to be more at A level that we tend to call it the base number, but it's basically our main number that we're working with. And the power, or the index, so the power or index is basically the number of times to multiply the base number by itself. So if we have a look at a few examples, so here 2 squared, or 2 to the power 2, means 2 times 2. So it means I'm going to have two 2's being multiplied together, which then gives me an answer of 4. If I had 3 to the power of 4, which is usually how you'd say it, you don't say 3 with a little number at 4, it's 3 to the power 4 means 3 4 times. So I've got 3, 3, 3, and I'm going to multiply those. And a quick way of working this out, well, 3 times 3 is 9. And 3 times 3 is 9, so 9 times 9 is going to give me 81. Then for 5 to the power 4, so that's going to be 5 times 5 times 5 times 5, which, working this out, is going to be 25 times 25. Now if you can't work that in your head, which no one will be expecting you to do, then all you need to do is just do some long multiplication. Whichever way you prefer, you'll get the same result. So 5 times 5 is 25, 5 times 2 is 10, plus 2 is 25, add a 0, 5 times 2 is 10, carry the 1, 2 times 2 is 5, so the answer is going to be 625. And then 6 cubed is going to be 6 times 6 times 6. So 6 times 6 is 36, times that by 6. So I'm just going to do a little bit of multiplication. So here we've got 6 times 6, which is 36, 6 times 3, which is 18, plus the 3 gives me 21. So the answer there is 216. Now there are commonly used powers, which are powers of 2, which are known as squared numbers, L squared, and powers of 3, which is known as cubed. Anything beyond those numbers doesn't really have, well, it does have an actual name, but you can just say to the power of 4, power of 5, power of 16, power of -2, whatever number. But if it's to the power of 2 or power to 3, we usually call it squared or cubed. Now you are expected to recognize the first 16 square numbers and the first 5 cube numbers, along with the 10th cube number. Now any others would be a bonus. So what is important is you kind of learn these just like you would like a spelling test in English. So for example, 1 squared is 1 times 1, which is 1. 2 squared, which is 2 times 2, which is 4. And it's these numbers here that you want to be remembering. 3 squared is 3 times 3, which is 9. 4 squared, which is going to be 16. 5 squared, which is 5 times 5, which is 25. 6 squared, which is 36, 7 squared, which is 49, 8 squared, 8 times 8 is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, and 12 squared is 144. Now as a bonus, we've got, sorry, not as bonus, we then got 13 squared, not 13 cubed, get excited my 3's there. So 13 squared is 169, 14 squared is 100, and then swap the 9 and the 6 round to give you 196. It's a good way of remembering. 15 squared is 225, and finally 16 squared is 256. Now again, ideally you want to learn all of these squared numbers up to 16. And like I said, we're not asking you to learn the 16 times table or the 13 times table, just know what 13 times 13 actually is. So then let's have a look at cube numbers. So with regards to cube numbers, again following the same sort of format. So here we've got 1 cubed, which is 1 times 1 times 1, which is 1. 2 cubed, which is 2 times 2 times 2, which is 8. Now again, always remember the most common mistake that people make is thinking 2 cubed is 6, because all they do is just multiply the base number by the power and it gives you the incorrect answer, which is wrong. So always remember that the power means how many times you've got to write the base number by. So that's 3 times 3 times 3. So 3, and again, ways to remember this is if you don't remember the answers, remember the technique of actually working it out. So 3 times 3 is 9, times 3 is 27. 4 cubed is 4 times 4 times 4, and 4 times 4 is 16, times 4 is 64. And again, don't feel pressured that you can't do long multiplication. So if you need to work that out, then do it. Go for it. 5 cubed is 125. Then 6 cubed, as we've already worked out, is 216. Then obviously you can then learn what 7 cubed is, what 8 cubed is, what 9 cubed is, and then 10 cubed, which is going to be 10 times 10, which is 100, times that by 10. What do we get? Well, we get 1000. And then to work out what 7 cubed is, well, that's going to be 343. To work out what 8 cubed is, that's going to be 512, and 9 cubed is going to be an answer of 729. So these ones here are going to be more like your bonus ones, but if you can remember it. But again, these questions usually are worth 1 mark, so you've got a minute. So if you can, in a minute, if you can work out what 8 cubed is, we know 8 squared is 64, so it's 64 times 8. If you can work that out in a minute, brilliant, you get your answer. So memory is obviously ideal, but if it's not imperative to you, then obviously you can, as long as you know how to work it out, you're going to be absolutely fine. Now when entering powers on your calculator, now when it comes to, what happened there? Let's get my calculator. So in terms of your calculator, now your calculator will be different because obviously there are loads of calculators out on the market, but hopefully you would own a scientific calculator. Now, in terms of powers of 2s, now what you should find is that you may have a button that looks like this, and this is to square numbers. And if I just get my calculator back, so my square button is just here, so that's what it looks like here. So if I want to do 5 squared, I just press that button. You can see it automatically comes up with a sort of superscript 2. Press equals, gives me 25. If I wanted to work out what 56 squared is, press equals, job done. Obviously if you wanted to, you could do 56 times 56, but again you want to try and be as efficient as you can and go for the square button. Now some calculators may also have a cube button. So for example, it may look like this, and this is to cube numbers. And some other calculators may have, let's say, a universal key. Now the universal keys are basically allowing you to enter any power you want, which it's not really called the universal power button, but I call it a universal power button. Now sometimes you might have this button where this is like an empty box. It may also be coloured in. You may also have a button that looks like this, or for more older calculators you may have a button that looks like X to the power of Y. Now using this, if I just get the calculator back, let's say I wanted to work out what, let's go for 3 to the power of 8 is. Now how I'd enter this on the calculator, I would either press the universal button if you've got this, and then enter 3 and 8 in the correct places. Or if I had, let's say, the arrow button, I would enter 3, then press that arrow button and then 8. Or if I had the XY button, I'd press 3, then press the XY button and then press 8. So again, if I just get my calculator has the X with a little box, so I enter 3, then that button, a little box comes up allowing me to press the button, enter the power, press equals, and I get the correct answer of 6,561. Now it does also work if I just press the button. All I've then got to do is just fill in the gaps. So just have a mess around with your calculator to make sure that you are getting the right answers, but obviously do check your answers. with what it should be. So for example, you should know your square number. So I know that, let's say 6 squared is 36, so pressing equals does give me 36. So it's always worth just knowing on your calculator where your power buttons are. And again, because squaring a number is quite popular, that's why it's got its own unique button, where you will have this universal button which is there, but obviously some calculators do have x cubed as a default button as well. So moving on then, let's move on to roots. Now a root acts as the opposite to a power and just returns a number that's been risen to a power back to its original number. Now, so for example, the opposite of squaring a number is to what we call square root. The opposite of cubing a number is to cube root, and the opposite of having a number to the power of 4 is to the fourth root. Now, there are other names for fourth roots, fifth roots, etc., but again, we just tend to call it that, and we don't need to go that mathematical. So square root is known like this. Now, sometimes you might be expecting a little 2. But generally speaking, that 2 generally doesn't pick because we call this a square root. Now cube root looks like a little 3, and then fourth root would look like a little 4. Now remember, the main difference is that root 3 is not the same as a big 3 in front of a square root. Now both of these two things would give numbers, but they are completely different. The latter is more a topic that in math that we call surds, which is a high GCSE A-level topic. So if you're working in year 7, 8, 9, the odds are you're not going to be working with surds just yet, but there is a big difference between a cube root and 3 root. So make sure that you are using the correct one. Now by recognizing square and cube numbers, it should be simple to mentally square and cube root numbers. So for example, if I just write down my square numbers again, so 1 squared, 2 squared, 3 squared, 4 squared, 5, 6, 7, 8, and let me just quickly write them all out. One. Then the square root of these numbers that I'm writing down here, which really, let's put in another colour. And apologies if this is messing up with your eyes. So the square root of 1 is going to return the number back to its original base number, which is going to be 1. Here, the square root of 4 is going to be 2. The square root of 9 is 3. Square root of 16 is going to be 4. Square root of 25 is going to be 5. Square root of 36 is going to be 6. The square root of 49 is going to be 7. Square root of 64 is going to be 8. So therefore the square root of 169 is going to be 13. The square root of 225 is going to be 15, etc. Now when we start moving into cube numbers, so again remember 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, etc. And then we move down to 10 cubed, which is 1000. So if you then had, let's say, the cube root of 27, you should recognize that 27 is a cube number. What do you have to cube to get 27? Well, that's going to be 3. The cube root of 125, or what number cubed gives you 125? Well, that's going to be 5. What's the cube root of 1000? Well, that's going to be 10. So it's important, and this is one of the reasons why it's really important for you to learn your square and your cube numbers off by heart by quickly recalling them. So when it comes to the roots, it just makes it a whole lot easier for you to then do. Now in terms of roots on your calculator, as I've already mentioned, the square root is a very, very popular function, which is why on your scientific calculator you should have a button that looks like this, or a button that looks like a root with a square underneath it. And if I get my calculator out, which is most common, you can see that it's just on that second row and the second button in, just next to the fraction button. Now in terms of using your square root, let's say for rooting, so this is a square root. Now again, if there is no number, you assume that it's square root. So if there's no number outside the little bus stop or little tick bus stop, or damage bus stop you could say, then it's going to automatically think it's going to be square root. So if I want to square root, let's say 49, I should get 7, press equals, it comes out with 7. So again, or alternately you could press the button first and then enter it. It doesn't quite work if you press 49 and then square root, because obviously the 49 needs to be inside the square root, not before. So it is one of those things where you have to press the button first and then go on. Now when it comes to cube root, some calculators may have it, but most roots need to be second functions. Now a second function or a shift function are, I'm going to struggle to zoom in if I can. No, I can't. So for these, it's basically what's written above the buttons. Now looking at this, if I look closely above my square root button, let me just do a very failed attempt. What I've got above it written in yellow is the cube root. Now to access this function here, which has been written on the calculator and not as a unique button, what we need to do is press the second function. I'm going to press shift and then this, and you can see there I've got my cube root. So if I do the cube root of 125 equals, it gives me the correct answer of 5. Now recognize that if I did 3 square root 125, that is not the cube root of 125. What that's going to do is going to do 3 times the square root of 125, and it gives me a long decimal answer. So that's the main difference. Now what happens if I wanted to, let's say, reverse, so for example, let's say we had the 5th root of 32. How do I enter this into my calculator? Now on your calculator, what you should have as a second function, you want to try and look for something that looks like this, or you might have a function that looks like this, or you might have something where the x and y's are reversed, so it's a little y with an x in there. Now I would say with most scientific calculators I've seen, these have all been second function. So again, looking at this calculator, it's just above my universal sort of power button. So here I press shift and then this, and then from that I can then enter what my root is going to be and what number I'm going to be rooting it to, so my base number goes inside. So for example, if I want to do the 5th root of 32, enter a little 5 and then a big 32 in the middle, press equals, and it gives me the correct answer of 2. Again, it's just worth just having a bit of practice like so. Now if you have got a certain calculator, you may have to think about how the order in which you enter the numbers. So for example, you may have to press 5, then press shift or second function, then the little XY button, and then press 32. So that's the order in which you may have to do to get the correct answer of 2. But again, it's just worth messing around. Unfortunately, I can't go through every single calculator, so it's just a case of just mess around and see what you get. So let's go through some common example questions. So with question 1, it's asking us to work out what 8 cubed is. So again, recognizing that 8 cubed is 8 times 8 times 8. Now 8 cubed is not one of the ones that we should know mentally, so let's have a look at working this out. So 8 times 8 is 64, so what I need to do is 8 times 64. Now again, it depends however which way you want to do it. So if you want to use grid method or use the column method, that's entirely up to you. So here we've got 480 and 32. So adding 480 plus 32 is going to give me 512. There is my final answer for that. In terms of 4 cubed times take away 6 cubed, well 4 cubed take away 6 squared, well 4 cubed is 64, take away 36. So just got to do 64 take away 36. And just doing the simple calculation, I get 8 and 2, so it's going to be 28. And then for this third one, again the cube root of 64 is going to be 4. The square root of 121 is 11. And 2 times 2 times 2 is 8. So this is the calculation that I then want to do. So I've got 4 plus 11, which is 15. Take away 8, which gives me a final answer of 7. Now again, if this was on, these questions tend to come more on a non-calculator paper, but obviously if it's on a calculator paper, well, it's dead easy. You just type the press the right buttons, and hopefully you should get the correct answer. So Question 4 says give two consecutive square numbers that add together to make 145. So what we're looking for is two numbers that are right next to each other in our list of square numbers that add together to make 145. Now in terms of tackling this type of question, it is a bit trial and error, but again, if you're just guessing, you could be there in 5 seconds, you could answer it in 5 minutes, in which time is of the essence. So what you want to try and do is write down all your square numbers that you know. So we've got 1, we've got 4, 9, 16, 25, 36, and we're going to only stop till we get to 145. So we've then got 49, 64, 81, 100, 121 and 144. Now in terms of this, we want added together. Now because the last digit is a 5, I'm looking for two numbers at the end that end in a 5. So basically they've got to be joined together. So 1 and a 4 adds to 5, but that's not going to make me 145. The next set of numbers that add together to make a 5, so here we've got 9 and 6 leads up to 15, so that does end in a 5, but again those two numbers aren't going to add up to make 145. And then we've got 9 and 4 don't, that makes 13. 4 and 1 makes 5, so we're potentially looking at these two numbers here, and in fact those two numbers do add up to 145. So let's just double check by adding those numbers up. And it's always good if you do get a question like this to actually show the calculation up. So 4 plus 1 is 5, and then 6 plus 8, which is 14, and there is my final answer. So the two numbers we've got are 64 and 81. Now if the question asked which two, now those two numbers aren't consecutive, so the numbers that are going to be consecutive are going to be 8 and 9, and there is my final answer. But it's definitely worth considering reading the question carefully. Is it asking for what are the two numbers that are square numbers that are consecutive add up to 145, or what two numbers that are squared added together consecutive add up to 145? So just be wary of how the question's written and how they want the answer being given. So the next one is very similar, but this time looking at difference. So it says the difference between two cube numbers is 56. Write down the two numbers. So again, if I look at my cube numbers, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. And again, if this was a calculator question, I could go beyond. If it's non-calculator, again, you're probably going to be using these cube numbers to try and make our answer of 56. So from this, I can see that these two numbers here subtracted, so 64 take away 8 equals 56. So here, those two numbers are either going to be 64 and 8, or I could say it as 4 cubed, writing done. So it's going to be 4 cubed minus 2 cubed, and that equals 56. And there is my final answer.